Hi friends, today we're going to talk about some interesting stuff, that is Arduino. Arduino. Before talking about Arduino, we discuss about microcontroller. So what is microcontroller? As we heard about microcontroller, it has various applications in field of electronics. For example, remotes, TVs and computers, which is considered as the best of human inventions. So let's talk about microcontroller first. So, microcontroller. Microcontroller is considered as a art of electronics. Microcontroller mainly consists of processor, RAM, and peripherals. So, let's first talk about processor. Processor is nothing but CPU. CPU performs arithmetic and logical operations. Without RAM, CPU is nothing because memory is stored in RAM and can be fed and databus. So, let's talk about peripherals. Peripherals mainly include inputs and outputs. For example, take this computer. Computer has many inputs and outputs. First, let's talk about inputs. Inputs are keyboard and mouse, and outputs are monitor and speaker. So avoid all this mess and comes to Arduino. Here is the Arduino. So here is 80 mega 168 chip, which is exact microcontroller, and here is the digital input output pins and analog input output pins, and this is power to the Arduino, and power can be supplied using 5 volts DC jack and this is USB port, which can be plugged into a computer using USB cable. Among digital pins, some are PWM pins, which can be represented by similarity symbol here. That is it. This is crystal oscillator and this is reset button.
To connect the temperature sensor circuit on microcontroller Arduino Uno. In this circuit, we use microcontroller Arduino Uno. This Arduino Uno has digital pins and this one analog pins. Temperature sensor LM35. From the data sheet of LM35, curved surface facing us. The left one is ground, the middle one is output, and the last one is supply. A breadboard and jumper wires after. Now we connect this circuit on the breadboard. This is breadboard. This is positive line of the breadboard and this is the negative line of the breadboard. But we don't use this positive and negative line. As positive and negative both we can use from microcontroller. And this microcontroller is power up using a 5 volt DC jack or by using USB cable connected to microcomputer. As we discussed earlier, this is LM35 temperature sensor. We know that the left pin is ground. And the rightmost one is output. So we connect this output to a analog pin A0. The right one is supply. We connect this to 5 volts on the microcontroller Arduino pin. The connections are over. These connections are so simple. Now we have to power up the microcontroller using a USB cable.
Explain the code for this temperature sensor using LM35. Let's get into this. Before getting into this code, from Arduino we need to take some values. Therefore, we need to initialize some variable to get this values from Arduino. So let's use temp in as this variable. Now I'm going to initialize this variable as global variable, and I'm assigning it to the input 0, analog input. Now if you see that there is a void setup block here. in that we generally initialize pin codes and variables or some other kind of stuff, but we initialize this temp pin as global variable, so we are not generally using that. And serial.begin, if you observe that the serial is as described in the comment lines, it's a communication between Arduino and this microcomputer that we are using. And begin is serial.begin entirely is just beginning the communication, and 9600 is a baud rate, is generally known as the speed rate. Like it varies from different devices, but is usually average value is 9600. And for comparing our RFID and some other shit, oh, it's before getting into this code from Arduino, we need to take some values. Therefore, we need to initialize some variable to get this values from Arduino. So let's use temp pin as this variable. Now I'm going to initialize this variable as global variable, and I'm assigning it to the input 0, analog input. Now if you see that there is a void setup block here, in that we generally initialize pin codes and variables or some other kind of stuff, but we initialize this temp pin as global variable, so we are not generally using that. And serial.begin, if you observe that the serial is as described in the comment lines, it's a communication between Arduino and this microcomputer that we are using. And begin is serial.begin entirely is just beginning the communication, and 9600 is a baud rate, is generally known as the speed rate. Like it varies from different devices, but is usually average value is 9600. And for comparing our RFID and some other shit, oh, it's generally baud rate value is 9600. It's an average value, but for devices like RFID and some other, the baud rate value has to be increased, and it's nonsense to discuss about it now. Let's get into this loop. Loop is something we already know, where the code is repeatedly runs. Now if we get into the next statement, here we observe that reading in the comment lines that reading Arduino values from temp pin. It is in the sense that the temperature sensors will give some values to the input called temp pin. An analog read is a keyword to read that values, and we are initializing these values to the variable called val. And as we know about this, Arduino works under the values between 0 and 1024. That means the temperature sensor giving some values to Arduino, and it converts into the ranges between 0 and 1024, and it does not in the form of the it does not represent Celsius. It's in the digits and binary and some other kind of stuff, which you later discuss in our blog. So we need to convert those values into Celsius and Fahrenheit, and now I'm going to use some formulas to convert those values. Sorry, it's 5. That's a Celsius formula, and now the values are also going to get converted into Fahrenheit. So let's do that. As you know that Celsius and the Fahrenheit relation, now I'm going to just write all the stuff down. Sorry, my bad. Celsius spelling. and it's a Fahrenheit formula. Now we need to print these values. That means we are actually going to see how temperature sensor is giving some temperature and detecting the temperature in our room in the form of Celsius and Fahrenheit, and we are going to see it in the mainframe of this computer. And it's a way to do this like this. See, like I said, serial is something that it enables the communication between a computer. Therefore, it also prints the values of the temperature sensors in our computer. So let's use it. Sorry. Edit చేసుకోవచ్చు. Here's the Celsius. Now I'm giving this /t to make the values so visible to you. You will later see it in that serial board that we're going to observe later. Now we're going here. I'm giving this print ln to make this into next line. You will clearly see it when I print those values, that why I given this print ln as blank. Here we're giving some delay so that you can clearly observe the values that you're going to see. Sorry, is this printing value? Now you can open. Now as it is completed, and I'm going to upload this code here. Uploading. How much time will it take for this? Uploading. Who designed this code, man? Shit. Uploading. At last it's completed. Now let's see how to. Here we am checking this. From here, see, if you observe the temperature from those, you can clearly get the room temperature. That's 34.67 degrees Celsius and 94.090 degree Fahrenheit.